Okay, so section 7.2 is talking about solving proportions using multiplication and division. So what you need to remember here is this is again is a middle level, like grade 6, probably 7. So students know how to multiply and divide, hopefully, all right, because you've taught them well. So they know how to multiply and divide. So here's just kind of maybe working out some rate problems or some kind of proportional problem, okay? And again, in this case, we're going to use a double number line, and we will also maybe use a strip diagram as well as visual models for this. And you can also use a table. But let's go ahead and start with this problem. All right, Joe's car goes 100 miles for every 4 gallons of gas. All right, that's pretty real world, right? Those of you driving. How far can Joe drive on 20 gallons of gas? All right, so the first thing we want to do with this is we want to go ahead and create a double number line. So let's start with a double number line. I don't know if you remember how to do those or not. So we have a number line here. And we'll go ahead and put this one, doesn't matter, we can do this one as miles. Okay, we start at 0 here. And then we have our second number line here. Whoop. And we'll start at 0, and this will be our gallons. So what we do know is that we know for 4 gallons, so let's just go with our 4 gallons here, that we can drive, or Joe can drive 100 miles. Okay, so we want to know, we want to get to 20 gallons. So can we get to 20 gallons? Our next one would be 8. Okay, our next one would be add 4. We've got 16. And we've got 20. So what we did on each one of these is we just added 4 each time. All right, so then here, because we're keeping this in proportion, I have 100, so this is 4 to 100, so I add 100 here, right? So we're gonna add 100, and we would have 200. We'll add 100, and we would then be at 300, 400, 500. So the question is, how far can Joe drive on 20 gallons? Well, here we are at 500 miles. So the answer to that would be, don't forget to label 500 miles using a double number line. So what if I said, so how far could he drive for 800 miles? Okay, how far could he drive in 800 miles? Well, can I still use my double number line? So if I look at the number line, if I go 200 miles, that's 8 gallons. If I double that, 400. So if I take this times 2, right, then I get 400. If I take this times 2, I get 16. Well, if I take this times 2 over here, I'm going to end up with 800. I might let out here. I'm going to end up with 800. And then what do I get here if I multiply it times 2? That brings me over here, and I'm going to be at 32. So that's just 32 gallons. All right, so I can kind of work with that number line. Now, what about finding just 1 gallon? Think about how I could find 1 gallon with that double number line. Well, if I kind of stick with what I did here in the halves, right, when we went from 2 to 400 to 800, if I go backwards and I divide by 2, I get 100. So if I divide this by 2, we get 4. So you kind of look for the patterns in here. So if I divide this by 2, I would have 50. Then I would divide this by 2. And if I divide this by 2, we'd be at 25. Divide this by 2, and we'd be at 1. So every 1 gallon is going to equal 25 miles. And so that's just putting into a part 1 with just a group of 1 only. Now I could have also said, well, what if I just divide this by 4? I get 25, and if I divide this by 4, we get 1. That's another way students are going to look at it. So that's why you want students to participate and say, oh, you know, they might divide by a half, they might divide by 2, excuse me, or they might divide by 4. There's different options that they can do. They might take 300 and divide by 6. That gets them to 50. 12 divided by 6 gets them to 2. Now I just have to divide by 2. So there's a lot of different ways that they can use these number lines, but they're really good visuals for them to determine this. Now our next section, 7.3, we're going to talk about unit rates. So I right now am not saying the word unit rate, but that's what this is. And this is just finding one group. All right, and so one group, and so 1 gallon would be 25 miles. Now, what's nice about once I know this is I could say, okay, well, what if I want to find 15 gallons? Well, when I look here, I don't really have a 15 because it falls in between. Now, not that I couldn't find it on the number line, I could. But once I know what 1 is, then I don't really have to do that so much anymore. I don't always have to use the number line. So here's a couple ways. Once I know what 1 is, we can say that 1 gallon, here's your gallons, and here's your miles. So we can say that 1 gallon is 25 miles. So how much would 15 gallons be? So this is what I want to try and find right here. So what did I have to do here to get 15? Well, I have to multiply times 15. So that means I'd have to multiply this times 15. So 25 times 15 would be 375. So now I'm starting to set it up into what we're going to eventually solve as equations, but write them as proportions still. And these are equivalent, 1 over 25, 15 over 375. Those are equivalent proportions. All right. Now, I'm going to show you another way on the number line that we could do that as well. So if I wanted to think about, I'm not looking at this part anymore. So let me I'll just go ahead and redraw it out so it's not so messy. Let's just go ahead and go, let's see, we'll start with we'll keep our 25 on there. Actually, I think I'm just gonna go with the hundreds. 1, 2, 3, 400. Let's just do that. Okay, and then on this number line, again, this is 0, 0, miles, gallons. So this one was 4. 8. All right. So what if, again, I talk about this question right here and I want to know 15 gallons. Just a little bit. I want to know 15 gallons. Well, I know I found it by doing this, right, with 1. But let's come over here and say, okay, what do I have to do here? So what do I have to do here? I could do this. I could take minus 1 here, and that's going to give me 15. Now, I could write it in between here. I'm just not. I'm just going to show the answer over here, okay? So if I subtract 1, that's going to get me to 15. Well, what is 1 worth? What is 1 gallon worth? Well, we know now that 1 gallon is worth 15. I'm sorry, 1 gallon is worth 25 miles. So what I do here to show it on a number line is I'm going to subtract 25. So then I have here 375. All right. So that's a way to show it on the number line, but we still have to know what 1 gallon is. We still have to know what 1 group is in order to do that. So here would be one way to show it on a number line, double number line. Here is one way to show it just as a proportion. Okay. Then when they get a little bit older, and even just probably 7th grade, not a whole lot, then they're going to come up with these type, and then they're going to be doing equations, which is what we're going to start working on in a little bit. But then this is going to be the cross multiplying, right? Where they take 1 times x is x, 15 times 25 is 375, and they solve it that way. I should always put a label on it. Okay, so this is a little advanced, and this is what a lot of teachers teach. And they just show cross multiplication and how to solve it. Students don't really know what that means. They don't really know what's going on with that. So really, this is not what I want you to focus on at all. All right, this is something they can use in the high school. Once they've learned these different ways, then they can start doing this when they start working on 1 2-step equations. But until then, so if I were to ask you to show me this in a couple different ways, I would want you to do a double number line is one way, and doing this proportionally would be another way. All right, so a couple of different ways that you can show that. Now let's do another one here. I'm just going to get another sheet of paper here. All right, so this is one actually that I pulled out of your book. Let's say we have, so they have lily oil to make a perfume. Okay, so they have lily oil to make a perfume is 3 parts. I think it's 3 liters, I believe. And then we have rose oil, and its part is 4 liters. So our part is 3 to 4. Okay, so the question on this is, let's say we have this, let's say we have 24 liters of lily oil. So how much rose oil is needed? Okay, so how much rose oil would be needed? So in this case, we kind of know, I'm going to go ahead and do this, write this as a, let's go ahead and do here's your lily. We'll do the rose, and we'll do the lily, and let's go and do a strip diagram with this. So how many parts are rose? 4 parts. And then how many parts are lily? Going to be 3 parts. Okay. Well, I want to know if I have 24 liters of lily oil, how much rose oil is that going to take? So think about what we just talked about. I mean, you could even do it on a double number line as well, but I just wanted to just use this strip diagram. So 24 liters, well, this right here, 1 part is 3. So if I take the 24 liters, and this is lily oil, and I divide it by how many parts, right? We have 3 parts, so how much is each part? Each part is going to be 8 liters. So, and lily, each of these, so when I do a strip diagram, these are all the same, they all have to be the same size. So that means these all also have to be 8. So how much rose oil is needed? Well, we have 1, 2, 3, 4. Okay, so we have 4 parts times each of them, which is 8. So 32 would be 32 liters of rose oil to 24 liters of lily oil to make the perfume. Does that make sense? Kind of bringing a little bit of what we did in 7.1 as well. But now we're just being able to find, you know, a total, we were able to find these parts through division, and they know how to divide, so that's nice. Okay, so what if, let's say we got asked, how about, let's say, just trying to think this through, let's say we have 20 parts. So now we have 20 parts lily oil. How much rose oil? What do we need for the perfume? So 20 is not as nice, right? Because it doesn't divide evenly. And that's okay, because students at this age can divide and deal with fractions. They know how to deal with fractions. So this one will be a little bit different. Here's the rose again, and here's the oil. Still have the same parts, 3 to 4. Whoops. So remember, when we have, you know, our parts are 3 to 4, 4 to 3, however you want to write that variable parts, these are our variable parts, right? So this is 4n, and this is 3n. And n is whatever we called before the number of batches. In this case, it's the number of liters, okay? And that's how we get these numbers. So we still over here are going to have 4n and 3n. We just don't know exactly what each of these are going to be. So let's figure out how we, just like we did up here. So if we have 20 parts lily oil, and that's 3, we have 3 parts. So let's take 20 divided by 3. And I would probably just leave it as a fraction like that. You don't have to put it into a mixed number. Now later, when you get a final answer, that might be good, because you can see how many whole there are and how many parts. So, but when I'm dealing with it like this, I would probably leave it as a fraction. So we know each of these are 20 thirds. Okay, so each of those are 20/3. So how much rose oil? Well, we have 4 parts times whatever each of them are. So we're going to take 4 times 20/3. So I always have taught to put this whole number over 1 and multiply straight across. There's lots of different ways to do that. So 80 over 3 liters. Well, maybe they don't know exactly what 80 over 3 is. So I might then say, all right, what is that exactly? I mean, I want to know how many whole liters there are in that. So we would just take 3 into 80. So 3 goes into here 2 times, right? 3 goes into here 6 times with a remainder of 2. So that's going to be the remainder over here. So 26 2/3 liters. But it's not any different dealing with a fraction than it is dealing with a whole number. It's just having to multiply through with a fraction. So then how many liters would the, well, we already know. Yeah, we already know that's going to be 20. Okay. All right. So that really is everything that I wanted to talk about on just being able to start setting up and solve proportions. All right, but we're going to get into the unit rate, which is going to help us a little bit more on our next section. So 7.2, and be sure that you look through your section in the book, just kind of read through that before you do your assignment. All right, guys, have a good one.